group of stuff called?
It's called
Cell phone.
cell phone ray.
Yeah, or
Cell phone ray.
micro.
Like a microwave.
Yeah, microwave and cell phone, radio, microwave, da, 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 higher and higher frequencies, and then what do we call it? You and I are glowing it infrared. You can't see this with your eyes unless you're an alien or bug. All right, there you go. I should do dashed lines because you can't see it, but whatever. What comes next?
UV.
Not yet.
UV.
Yep, visible, right? Visible. So what are the colors in order? Now this is an important thing.
Red, orange.
There's red, but there's lots of reds that our eyes would say red. And then there's what?
Orange.
Orange and yellow. Lots of things that would start going like, oh, the red's looking orange, and the orange is looking yellow, and I don't have a yellow pen.
Green.
Green.
Blue.
Ah, some greens.
Blue.
Some blues.
And purple.
And some, which we call what?
Purple and violet.
Violet. Violet. And what's more than violet?
Ultraviolet.
And there's all these, so just know that there's lots of frequencies of violet, and then there's good old UV. Again, you can't see it unless you're a bug or whatever. What's more than UV? X-rays. What's more than X-rays? Gamma. And that's important for stars. So just know it's all light. It's just really high energy light. Consequently, this stuff can be dangerous or damaging. What blocks UV in our atmosphere?
The ozone.
Ozone, what layer? Yes, I'm so thankful for you knowing that. And I'm thankful for the ozone too. That's the thing to do. Like when people go around the table, like, what are you thankful for? I'm thankful for the ozone because otherwise we'd be sterilized. So, yeah. Anyway, so. And so here's a whole range. So when something gets hotter, it glows. So here's what I want to talk about. I'm going to introduce something for chapter 11, stars. We're going to take a look first at cool room temperature, even a refrigerator. So it can even be cold. I'll say cool. And let's draw a line here. And then we've got a warm room temperature, kind of like this, or the way it was at the beginning of the semester. Anything in there. Warm room temperature. And then we've got things that glow red or a red orange. And we're going to keep going some more, but let's start with these guys. So you can see that I'm getting hotter. Okay, so something in a cool room temperature will glow a range of colors. A range of colors. If we turn off the lights, will objects in the room be glowing visible light? No. What will they be glowing?
Black.
Infrared. So at that temperature, and the brightest one, maybe I'll do it that way. I know. Change. So things at a cool room temperature give off this range of infrared. Okay, so I'm going to go like this. I'm going to go like here to here, say. It's giving off all these frequencies. This is the lowest frequency. This is the highest. Which frequency tells me the temperature? The brightest. So you need an instrument. Obviously, you can't even see infrared, but we got instruments that can measure the infrared, split it up like you're going to see, and we can figure out which one is the brightest. Now, I don't know, maybe I should make that black or whatever. And you can, sometimes you'll see graphs, and the brighter ones get taller, or you can just make it brighter. So this one is the brightest, and it happens to be in the infrared. Brightest. So that says brightest infrared. I'm picking out the one in that range that's brightest. Brightest frequency tells the temperature. Okay? That's the idea. What if things get warmer? What happens to the range? Everything glows brighter. So the whole thing's going to be brighter, and brighter is a weird word because it's infrared, you can't see it, but we get more in our instruments. And we go to higher frequencies. So watch this. So in a warmer room, it's going to get some of these guys out here, but no red yet because I can't see it still. So it's still in the IR range, but it's all going to be brighter. Which one are we going to look for? The brightest one. And it's going to be in the infrared. So you and I are glowing a range of infrared. If someone had a meter and picked out the infrared frequency that we glow the most, the brightest, put it in Wing's law, you could get our temperature. You can tell temperature that way. And now we can do it pretty easily that way. Now, as something gets hotter, it starts glowing more frequencies. It even gets out here into the reds. Everything is brighter. Which one are we looking for? But which one? Which frequency do we want? Not the lowest, not the highest, the brightest. And the brightest one is still in the infrared, but notice that I went to a higher frequency, right? So what's happening is the frequency is still infrared, but we are getting red. And maybe some orange. So what you see is this over here. Our experience is, reds and oranges. You don't see it in infrared, but if you pick it out, the brightest ones, you don't have to memorize that, but just get this sense. So now you're going to make it hotter, or look at a hotter star. And what you see then is an orange star, and you might need a telescope to separate. These kind of look the same to your eye, but as you go into an orange star, what you're going to see is, again, it's jiggling, it's hotter, it's jiggling faster, and so what you're going to get is more of this stuff way out here. You might even get some green out here. So we can throw in some greens. Got some greens and some little bit of greens out there. Some yellows and oranges. Maybe some reds. Out in there. And the brightest one is going to be red. A particular red, and then you got all this infrared out here. And so can you see how the brightest frequency is shifted to higher frequency? And you take that, put it in, boom, you got the temperature. It's a great tool. Cool. So the reason you see orange is, what you see is a combination of the visible light with your eye. Detect that. Now, let's go 3 more. What other color did we see in chapter 1? Almost.
Yep.
Let's go yellow. Kind of like our star, right? So we got a yellow star. And now we see why they're different colors. Oh. Well, what's happening with a yellow star? So you're going to get all these frequencies. They're going to all glow brighter. All brighter. You got the lowest frequency and the highest frequency. Out here into some blues. A little bit of blue, you know. A little bit of blue. Not very bright, but a little bit. You got some greens in there. You got these reds. You got this infrared over here, whatever, you can't see that. Right? And you got yellows, and the brightest one is going to be somewhere in the sort of yellow to green region. And that tells the temperature, depending on the temperature here. But your eye is going to see all these colors and combine it in your experience, because color is an experience. It doesn't exist in the world. It's our experience. What exists is different frequencies. Weird. So just throw that out with dessert or something like that. So we're going to go two more. What's the next color?
Green.
We don't see green, and this is interesting because well, we are seeing green. We see this combination. And we're going to talk about that. I'm so glad you said that.
Blue.
Well, what happens, and you're about to see this, is you see a lot of the colors. In fact, you see a lot of this, of the Roy G. Biv. You get out here, and you actually get some UV and stuff like that. So you get all these colors and violet, and I'm running out of colors and all these colors. And the brightest one is going to be somewhere in the blue-violet region. But you're going to see violets. You're going to see Roy G. Biv. You're going to see blue. Lots of bright blue. You're going to see bright greens. Yellows and oranges somewhere. Reds. And what is your experience when you see Roy G. Biv?
Rainbow.
Rainbow. And it's the brightest one. Notice how the brightest frequency has increased way over to here, somewhere in here, depending. When you see all the colors put together, when you separate them, you'll see a rainbow. When you put them together, I'll show you in just a second. And the last one that we saw in chapter 1, we looked up and we noticed stars, and we didn't know. We were just ancient shepherds back then, but we've lived thousands of years now. What color do we see? Blue, white. And notice that these are hotter. And so what happens in this range is actually the brightest one is ultraviolet. Good luck seeing it. But you see a lot of blues. So you see all Roy G. Biv bright. That gives you white. Lots of blue. And you see the brightest is in the UV. And all we have to do is have instruments we couldn't do it till we had the right instruments. Get the instruments to break the light down, find the brightest one. Our eyes aren't very good, dependable. But let me show you this and just you turn off the lights and you're going to take a look. I want to give you one just up for your notes because we're going there. This is chapter 11 preview. Chapter 11 preview. These stars are called M stars. These stars are called K stars. Okay. K stars. These stars are called G stars. These are F and A stars. And these are O and B stars. We categorize these stars. And this is called the spectral class. Don't worry, just put it down, we'll come back to it. But if you look up particular stars, they'll be listed as an O star, or K star, or something like that. You good? Oh, spectral class. Yeah, S-P-C-T-R-A-L class. Now we got, and they're just, I say this because they don't, in the past, women didn't get enough recognition, and now in most places, certainly in universities, we know all you got to do is look around. You see your professors are women, and they're smarter than you, and whatever. So whatever. So, but they're, obviously it's not an issue. Anybody seen Hidden Figures?
Yeah.
Great movie, right? We're talking 50s and 60s. And they were called calculators because they know, like, fancy calculators. They were doing this stuff. Now, the problem with that movie, the thing I don't like is that those women were incredibly brilliant. So, like, just because they were doesn't mean, there's a lot of other people in the room who happen to be men that weren't as brilliant, nearly as brilliant, but they did good work. It was important work. So, but they were particularly, of course, they had to get recognition. They had to be that much better, right? But now we know. So we know that it's healthy to have a diverse environment with just much richer environment and healthier. Anyway, good old Henrietta Leavitt around 1900 was part of the Pickering women, or the Harvard calculators. Oh, go take care of this. Meanwhile, they're taking care of and doing this analysis and profoundly changing the way, discovering things that were mind-blowing. Henrietta Leavitt here, Annie Jump Cannon, I'll mention you, part of that group, discovering these things. So, just as an acknowledgement of their profound contributions and hard work and brilliance. Speaking of brilliance, take a look through your, everybody got this, and you'll do better if you move closer. I encourage you to move closer. And here's how you're going to do it. You're going to look at something. Let's say, look at this. Okay, look at it and put it right up to your eye. And then do this. Watch my shoulders. I'm just going to rotate my shoulders until I see a range of frequencies. Of course, only visible light. So you're going to go like that. So I'm going to do that with this first. Okay, and then I'm going to turn off the lights. Here's going to be, what color is that to your eye? Just look with your eye first.
White.
Right? So there's white. There's a white star, right? So there's white. That's your experience as white. But what frequencies combine to give you the experience of white? Well, let's see. So look straight at it and then rotate to either side. Oh. What do you see?
Rainbow.
Red, orange. I see all the way up there.
Roy G. Biv, right?
I see that.
Everybody see Roy G. Biv?
No.
Red, orange, yellow. So those are different oranges. A little bit of yellow, which your eye would say. Sort of different greens, different blues, different violets. Everybody cool? And whichever, and we can measure how far they go out. That tells us the wavelength. We do a little math, a little trigonometry. And look at both sides. See, when I'm close here, it's really close. So the closer you get, the better, the easier it is to see this. Everybody cool? Let's try this. Ready? Let's see if this works.
Wait. No. Yeah, it's not coming out.
You sure?
Wait. It was a little bit. No, yeah. There you go. Oh, yeah. Wait, put it down. Wait. Yeah. Yeah, right there. There
Good.
you go. Yeah.
Reggie Biff. Yes. Yes. All right. So, yeah.
Did you actually get it?
Yeah, I think so. I've done it before. That's cool. Okay, wait. Let's do this. Okay, ready?
Too late.
So which one of those? What would tell us the temperature of that? The brightest one. Now, it's hard to tell with our eye again because we are biased. Our eyes don't see all colors equally. So now, is this glowing? So I should have. Boom. That's nice. Right there, right? You can really see good old Roy G. Biv. So now, so the point is here, our experience of all the colors together is white. And since white gives off a lot of all the colors, I mean, if a white star is giving off a lot of the colors, that's why we see it as white. Now, this is giving off not quite as much, so we see it kind of white, but it's definitely got a little yellow tinge. As it cools, it has more of an orange tinge, because there's a lot of red-orange that dominate. We don't see green because as we start picking up the green, the other ones are brighter. When we start picking up some of that green, then the blue takes over too. So we don't see green. We don't see purple stars or green stars. That's a question to make sure you know because it wasn't in our chapter. So this is how we see that. Now, is this glowing?
No. Until you turn it
Not
on.
that we can detect.
Is it glowing?
Until you turn it on.
Is it glowing?
Yes.
Yes.
What's it glowing?
It's going red.
Infrared?
Infrared.
Oh.
Right? I was just seeing if there are any aliens or bugs around among us. Okay, so now you're gonna move or whatever so you can see this. What I want you to do is watch it with your eye and then look at it straight through and then rotate to the side how much. I'll get rid of this in a second. Right now it's glowing infrared. I turn off the lights, you can't see it below. But if I, now watch it. I'm going to make it get hotter. And as it gets hotter, it'll start throwing out a little red.
I can't even see which way.
Hold on. You'll see it. There. See it?
Oh, yeah.
Oh.
There it comes.
Oh, wow.
Look. See it?
Oh.
So now you're seeing a combination of frequencies. And what's happened as it got hotter is it started added higher frequencies like the reds. Some reds and some oranges. And what else? Look through your diffraction grating.
I see mainly reds and oranges.
You see reds and oranges, but keep going. What else do you see a little bit of?
Is that like a light yellow or green?
Green.
Oh, I can't tell. I'm colorblind.
Look off to the side. Keep going. Rotate your shoulders to the side.
I see white.
I see white.
White?
I see white. I see red. I can't see it.
Wait, look straight at it, and then rotate to the side.
Orange, green, a little bit.
Violet?
White?
I see two lines to start.
Well, say, turn up the cell phone back. It's killing us. Okay, that's probably it. Yeah, that's good.
Like orange, yellow.
Yes. You see now?
Orange, yellow.
Oh, I see orange.
I see orange, yellow.
You see a little green?
Yeah, orange, yellow, green.
And there's all right. So,
Orange, yellow, green.
all right. Now you see the light.
Yeah, not the
So look what you saw. It looked orange. It was a K star. Well, it's not a star, but well, why? It's actually got some green in there. Now, some artists are just weird, but so are scientists. So they can tell. They can. Oh, there's a little green in that. You go, how do you see that? It's like Cooks, It's like, oh yeah, there's a little tarragon in there. It's like seriously, but it's cool, right? Oops. All right, so that's how you tell the temperature of a star. You gotta just break the light down because you can't go there, and that just opened up.
Did you?
Any what?
Glasses.
Oh, glasses. That'd be like really tricky. Oh, that's an invention. You should make glasses with. They're really cheap, but I do actually to ask you to return them because. Now, this is important.
That's yellow.
You guys, we just figured out how you tell the temperature. Now, this is key. When you have a hot, solid object or very packed in gas, it will glow a continuous range of light. The brightest one tells us the temperature because some brilliant, hardworking is the real key. You don't have to be brilliant to be a scientist, you have to just work hard. So that's the key. On the outer part of a star, there's kind of more of an atmosphere, we might say, where the gas is thinner. And something happens when the gas is thin. It doesn't do this. It does something else. So let's get that, and that'll tell you what kind of atoms the star is made of, and you can even analyze the heck out of it and figure out how much of each kind of atoms. It's crazy. And we use this as huge, maybe if there was one most important tool of science, this could be it, called spectroscopy. You don't need to know that. Okay, so let's do that. All right. So glad you're recording this. I hate that some people miss this. So like, you guys did well for getting here, so yay for you. Plus, it's hopefully fun. All right, there's a difference, and I'm gonna show you some cool things. So let's write this down. Everybody got that? Cool.
You can erase it, don't worry.
All right. Thank you. I have coach approval.
Don't have my approval.
Yeah.
You're the teacher.
Yeah. I'm the teacher. That's second. You're the student. That's first. That's why we're here. Yeah. Thank you. Okay. So let's write this down. I'll try to write it in a clear way, and then I'll demonstrate it. And then of course there's the book, which I know I need to rewrite, but it's getting there. Second edition coming someday. Oh, press the the glowing button. One side or the other. Yes. All right. So here's the story, and then I'll show you glowing thin gas. And we'll come back. Composition. Not as in that paper that's due after you come back. Composition. No, I don't know.
Oh.
No, I don't do that. I know what you guys do with those papers. Not that I didn't. Tells the kind of atoms a star is made of. Without going there, we can tell what that thing is made of. Remember, stars are all hot gas. The inner parts, the main parts, are dense gas. The outer layers are thin, if you will, not dense gas. And that is the focus now, and I'll show you what happens to thin gas. Two things. And what we're going to get out of this, and I think, let me write it this way, is we're going to get that these give line spectra. Line spectra, bright or dark, it doesn't matter, it'll tell us the same information. Line spectra. You getting all this?
Yeah.
I love technology. I love YouTube. Dangerous, isn't it? Okay, so here's the story, and then I'll show it to you. Behind the scenes, and we could talk about it, and I have tried to do that, but we're just going too fast, and people can't absorb it. So, okay. It has to do with electrons orbiting the nucleus and going out and dropping in and things like that. So you could learn more about this, but I think we want to hold to the whole story in the picture. So here's the story. I'm going to talk about hot, thin gas, and then cool, and here it is. Hot, thin, which means not dense, not packed in. Gas of any one particular type. of atom only glows, so any kind of atom, say hydrogen. Hydrogen only glows certain frequencies. You can never get the other frequencies from hydrogen. Helium only gives off certain frequencies. Carbon, only certain frequencies. It can't give the other ones. Only glows certain frequencies. Frequency lines. You'll see them. You're going to see them. So when it's hot, we get a bright line range or a spectra. That could look something like this. A particular red and maybe a little different red. But it's not continuous like you just saw. There are gaps. There are gaps. Well, if we want to talk hydrogen, we got a little so there's only certain colors that it glows. And then other ones will glow, so different atoms will glow different sets. So if you just look and see what set of colors you get, that tells you what atoms there. Different atoms glow different sets of frequencies. It's kind of like a fingerprint. You got those frequencies, you know what atom it is. Does that make kind of sense? Not worry about why so much right now. Now, if that same gas is cool, this is a little bit picture. If that same gas is cool, and all the frequencies, or rainbow if you will, for visible light, shine through it, they shine through the